So, question number 11 says, explain why there does not exist lambda in C such that lambda into this quantity is equals to this quantity. So, if we suppose that this equation is true, then by that what we mean is lambda into 2 minus 3i equals to 12 minus 5i, and lambda into minus 6 plus 7i equals to minus 32 minus 9i. Let this be equation 1 and let this be equation 2. If I divide 1 by 2, then what I'll get is lambda into 2 minus 3i equals to 12 minus 5i by lambda into minus 6 plus 7i equals minus 32 minus 9i. Lambda and lambda will get cancelled, and if I cross multiply, I'll get 2 minus 3i into minus 32 minus 9i equals 12 minus 5i into minus 6 plus 7i. So that will mean when I'll calculate this, I'll get minus 91 plus 78i equals minus 37 plus 149, which is never true. Therefore, such a lambda will not exist in C. Moving on, show that x plus y plus z equals x plus y plus z. Here, the part that we have to concentrate is that x and y and z belongs to f to the power n. So here what we can do is take x as x1, x2, so on till xn, y as y1, y2, so on till yn, and z as z1, z2, so on till zn. Now, calculating the first x plus y plus z, this will be equals to x1, x2, so on till xn plus y1, y2, so on till yn. Then after calculating this, I have to add it to z1, z2, so on till zn. So when I'll add x and y terms, I'll get x1 plus y1, x2 plus y2, so on till xn plus yn. And then this, I have to add it to z1, z2, so on till zn. So when I do that, I'll get x1 plus y1 plus z1, comma x2 plus y2 plus z2, so on till xn plus yn plus zn. So let this be equation 1. Then we have to check x plus y plus z. This will be equation 2. If you calculate this, you'll get the same thing. So that is why these two are equal in f to the power n. Now, question number 13 says, show that ab into x equals a times bx, where x belongs to f to the power n. Again, take x as the ordered pair x1, x2, so on till xn. So first find ab into x. This will be ab into x1, x2, so on till xn. So when I calculate this, I'll get ab into x1 AB into x2 so on till AB into xn. Then what I can do is group this up. A into B times x1, A into B times x2 so on till A times B into xn. Then this is nothing but A into bx. Therefore AB into x equals A times bx. Moving on to question number 14. Show that 1x equals to x for all xn f to the power n. Here again, take x to be the ordered pair x1, x2, so on till xn. So 1 into x is nothing but 1 into x1, x2, so on till xn. This is nothing but x1, x2, so on till xn, which is in turn just x. Therefore 1x equals to x. Moving on, here they have asked us to show lambda into x plus y equals to lambda x plus lambda y. Again, x and y belongs to f to the power n. So take x as x1, x2, so on till xn, y as y1, y2, so on yn, and then calculate the first part of the equation, that is lambda times x plus y, which is lambda times x. Here x is x1, x2, so on till xn, plus y1, y2, so on till yn. So lambda times x1 plus y1, x2 plus y2, so on till xn plus yn. So let this be equation 1. Or instead of, we can just split it up here. I'll show you how. So now what I can do is multiply lambda throughout. So this will be lambda x1 plus lambda y1, comma lambda x2 plus lambda y2, so on till lambda xn plus lambda yn. And now what I can do is I can write the x term separately and the y term separately. So that is lambda x1, lambda x2, so on till lambda xn plus lambda y1, lambda y2, so on till lambda yn. So this is nothing but lambda x plus lambda y. Therefore lambda times x plus y equals to lambda x plus lambda y, and x and y belongs to f to the power n and lambda belongs to f. Moving on, show that a plus b times x equals ax plus bx. A and b are from f and x is from f to the power n. Again, take x as the ordered pair x1, x2, so on till xn. Then a plus b times x becomes a plus b times x1, x2, so on till xn. I can write this as, when I multiply a plus b throughout this, I'll get a plus b times x1, a plus b times x2, so on till a plus b times xn. Then what I can do is split it just like the previous problem. ax1, comma ax2, so on till axn plus by1 by2 so on byn. Now this is nothing but ax plus why did I do this? I'm so sorry. Plus b into x1 p into x2 so on till p into x1. So this becomes ax plus bx. Therefore a plus b into x is ax plus bx, and that is the end of exercise 1.8.